Hello, geometry students. I hope you are doing fantastic. We are going to be doing notes for 10.3 today. So we're still on our chapter on circles, and today's topic is on using chords. So again, all you need to have is a piece of paper and a pencil. We're going to do a few theorems and then several examples that go with that. So our first theorem is going to be called the congruent corresponding chords theorem. You don't actually need to write that part down. But it tells us that in the same circle are two congruent circles. Two minor arcs are congruent. I'm going to show that by putting double dash marks there. If and if they're only if their corresponding chords are congruent. So for example, if the two chords are congruent, then the minor arcs are. Or if the minor arcs are congruent, then the chords are. Let's do an example. Let's put some numbers on this. Let's say that both of these chords are length 6, and this arc is marked as being x point plus 2, and this one is marked as being 3x. I would be able to set x plus 2 equal to 3x, subtract x from both sides, and get that 2 equals 2x or x equals 1. So if the chords are congruent, the arcs are, and if the arcs are congruent, then the chords are. All right, we can also do another example like that, and I'm trying to think if I should do that now or later. I'll do it now. So let's just call this example 1, and then for example 2, I'm going to show you another circle, obviously, and this is not drawn to scale. I can try to make it a little bit better here. But let's say we have a circle where both these chords are the same, and I want to know what is that degree there. The thing for me to notice in this situation is that if this is x degrees, this would also have to be x degrees, because if the chords are the same, then the arcs would need to be. So I also know that all three angles have to add up to 360. So I would have 2x plus 90 equals 360. When I subtract 90 from both sides, I would get 2x equals 270, and then dividing by 2, I would get 135. So that is the basic value that I would get there using the first theorem. Let's go ahead and look at a few more theorems here. So the second theorem is going to be called the perpendicular chord bisector theorem. So let's go ahead and look at that one. Again, you don't need to write down the name, just draw the picture. So if a diameter or radius of a chord, of a circle, is perpendicular to a chord, then it bisects the chord and its arc. So that's the picture you would need to have for that one. If the diameter or radius is perpendicular to the chord, then it bisects that chord. That means cuts it in half, as well as its arc. The same thing can be true of the converse. If you can see that this chord is bisected and the arcs is also bisected, then you know that the segment intersecting the chord has to be either the diameter or the radius. So let's do an example on this one where it says find the value of x. And in this particular case, we are just given a picture where we can see that the diameter is perpendicular to the chord, and then the first part of the chord is marked as being 2x plus 4, and the second one is 3x minus 2. And we do know that those two pieces are going to be congruent because the diameter is perpendicular to the chord. So I can set 2x plus 4 equal to 3x minus 2. Then I would do my opposite operations twice, and I would get that x is 6. Okay, let's do another example using that. We'll do 2 more examples using that same theorem. So let's see, that would be example 3. Now let's do example 4. In this particular triangle, we're going to call, circle, we're going to call the circle G. And then let's go ahead and draw a right angle here. In circle G, the measure of arc DEF is 150 degrees. So if you took a marker and highlighted all of this arc right here, it would be 150 degrees. Now, if you think for a minute, we can see that this radius is perpendicular to the chord. So we know that it has to bisect the chord as well as the arc. So each individual arc would have to be 75 degrees. And that's actually what they wanted us to find in this one, is to find the measure of arc DE. In this case, it would just be 75. Okay, now let's do another example where we use the converse. In this particular example, again, we have a circle with a diameter and a chord, and we can see that there's a right angle here, and that these 2 pieces of the chord are the same. If I want to label the diameter AB and the chord MN, the question is asking, determine if AB is a diameter. We would say yes, since MN is perpendicular to AB, then it bisects AB. Oh, and it bisects AB. And it bisects AB because this piece is 15 and that piece is 15. Then AB is a diameter. So this would be the converse of the theorem, where the perpendicular bisector of a chord has to be a diameter or radius. We know it's perpendicular because of the right angle, and we know it's a bisector because both pieces of that chord are the same size. Now, there is one more theorem. This is called the equidistant chords theorem, and again, you don't have to know the names or theorem numbers. You just have to know what the theorems mean. So this tells us if you have the same circle or 2 congruent circles, 2 chords are congruent if and only if they are equidistant from the center. What that means is if those 2 chords are the same distance from the center, they are congruent. It also means if they're congruent, they're the same distance from the center. So let's do an example here. And this is going to be the converse that we're going to do. So this will be example 6. In this particular example, the first chord is going to be EF and the second one is going to be GH. And they're going to tell us for the directions that EF is equal to GH is equal to 24. So in other words, this chord is 24 and that chord is 24. We know from the converse of the theorem that we just did that because these chords are congruent, they must be the same distance from the center. So if EF is 4x minus 3 units from the center and GH is 2x plus 3 units for the center, it must be that I can set those equal to each other. If I do, again, I can use my opposite operations. So then I'm going to get 2x equals 6 or x equals 3. Okay, these notes were relatively straightforward and short, but we will go over them more during the Zoom. But I so much appreciate you guys taking the notes And I look forward to seeing you in class. Thank you.